Perpetual motion, a concept that has captivated inventors for centuries, refers to a machine that can operate indefinitely without any external energy source. Such a machine would revolutionize the world, providing limitless clean energy. However, the laws of physics, particularly thermodynamics, present a formidable barrier to its realization. Despite this, the pursuit of perpetual motion has led to a rich history of ingenious inventions and thought-provoking concepts. The quest for perpetual motion has a long history dating back centuries. Throughout the ages, inventors and scientists have been captivated by the idea of creating a machine that could run indefinitely without an external energy source. This pursuit has led to numerous fascinating designs and concepts, each reflecting the ingenuity and creativity of their time. One of the earliest examples is Bhaskara II's wheel, a remarkable invention from ancient India, featuring curved spokes with mercury reservoirs. The design was intended to harness the shifting weight of mercury to maintain continuous motion. The idea was that shifting mercury would create an imbalance, causing perpetual spin. This concept, while innovative, faced practical challenges. Another example is Robert Boyle's self-watering pot, an intriguing device from the 17th century, using capillary action to create a perpetual water loop. Boyle's design aimed to utilize the natural properties of water to achieve continuous operation. These designs, while ingenious, ultimately failed due to their reliance on principles bound by the laws of physics. The limitations of energy conservation and friction always come into play. They serve as a testament to human ingenuity and the enduring fascination with limitless energy. Despite their failures, these attempts have paved the way for modern scientific advancements and continue to inspire new generations of thinkers and inventors. The laws of thermodynamics stand as barriers to perpetual motion. These fundamental principles govern the behavior of energy and matter in our universe, setting clear boundaries on what is possible. The first law states that energy cannot be created or destroyed, only transformed. This principle, also known as the conservation of energy, ensures that the total energy in an isolated system remains constant. This implies that any machine cannot produce more energy than it consumes. In other words, a perpetual motion machine of the first kind, which would generate energy without any input, is impossible. The second law introduces entropy, dictating that some energy will always be lost as unusable heat. This law highlights the natural tendency towards disorder and inefficiency in any energy transfer process. This inefficiency poses a significant obstacle to perpetual motion. Machines inevitably lose energy through various forms of friction, heat dissipation, and other interactions. Any machine will experience energy loss due to friction or interactions with its surroundings. These unavoidable losses prevent the machine from operating indefinitely without an external energy source. These losses accumulate over time, causing the machine to eventually halt. The dream of a self-sustaining, never-ending machine remains just that, a dream. The laws of thermodynamics highlight the inherent limitations imposed by physics. They remind us that while we can strive for efficiency, perfection in energy use is unattainable. Despite the barriers, the allure of perpetual motion persists. The idea of a machine that can run forever without any external energy source has fascinated inventors and scientists for centuries. From ancient times to the modern era, the quest for perpetual motion has been a symbol of human ingenuity and ambition. Imagine a world where energy scarcity is a distant memory, with machines operating indefinitely. This utopian vision fuels the imagination, promising a future where energy is abundant and free, transforming our cities and lives. This vision drives the pursuit of perpetual motion even against scientific consensus. Inventors tirelessly work on new designs, hoping to overcome the seemingly insurmountable challenges. The potential benefits extend beyond solving energy woes, revolutionizing industries and reducing environmental impact. Imagine factories running without fuel and power plants emitting no pollution, drastically cutting down our carbon footprint. However, the laws of physics suggest that perpetual motion is impossible. The first and second laws of thermodynamics, which govern energy conservation and entropy, present insurmountable barriers. The conservation of energy and inevitability of entropy pose fundamental limitations. Energy cannot be created or destroyed, and systems naturally progress towards disorder. The pursuit of perpetual motion has yielded valuable insights into energy and physical laws. These efforts have deepened our understanding of how energy works and the fundamental principles that govern our universe. It showcases human curiosity and the drive to explore the boundaries of possibility. The quest for perpetual motion, though ultimately unattainable, continues to inspire innovation and discovery. While skepticism remains, scientific progress leaves open a sliver of possibility. History shows that insurmountable barriers can be shattered by groundbreaking discoveries. New theoretical frameworks might challenge our understanding of energy and matter. Exotic forms of matter or undiscovered energy sources could potentially circumvent current limitations. However, such speculations require rigorous scientific proof. The pursuit of perpetual motion continues to inspire, pushing the boundaries of human ingenuity and exploration. Please like, comment, and subscribe to our channel for more fascinating content.